just like we have shown in our example. For example, in this case, the key is used to encrypt your fingerprint. So even if the TE is cracked, all the hackers can get is just the encrypted data, not the raw fingerprint. So your data is still safe. In our real world, there are many solutions about on TEs. As for example, the Intel, they have SGX, and AMD, they have something said SEV, and with some extension named SMP and ES. And ARM have their own solutions named of CCA. For now, we just use the Intel SGX because it is proposed very early in 2015, and the tool chain and the support materials of it is the best among the three solutions. The Intel SGX is introduced in 2015 with the 6th generation of Core CPU, and it have a secure crypto process as I have just presented, and also Intel introduced an actual instruction set to it. So developers can use it to develop secure programs. And when the SGX is enabled, we say the program is executed in something named enclave. Enclave is an isolated space in the CPUs. It has many important features. The first feature is that all its memory data is encrypted, just as we have shown in our fingerprint examples. And all its data is only decrypted when the program is really execution and the CPU tries to access the data. Then it's decrypted and the CPU executes on it. Then it's re-encrypted again and right back to the memories. So during all its lifetime, the data is encrypted. And so the only attack chance is that when the data is executed in the CPU at that moment, if the hackers have the ability to hack into the CPUs, then he can see the plain text of your data. And I think such probability is very low, and it requires very senior attackers to do this. So that's why we think Intel SGX is very safe to use. Although there is some reported vulnerabilities in Intel SGX in the academia, but in the real world, no, to my best knowledge, I haven't heard any real world attacks on the Intel SGX for now. Okay, then we can come to the cloud computing scenarios. The cloud computing scenarios is a little different from the ones of the fingerprint example. Because in the fingerprint example, your cell phone is just on your hand, and all it's need to do is very simple. It's just need to encrypt some important privacy in it. Also, the program logic is determined when it is manufactured, right? It just need to handle the fingerprints. It just need to connect to the fingerprint sensors, and all is done. But in the cloud computing scenarios, the things are different. First, we have untrusted platforms. For example, if you are using the AWS from Amazon or the Google Cloud from the Google, you can see that their OS kernels are customized. And for example, Google will pre-install many statistics and monitors into your system. So whether we can trust this operating system is hard to say. Also, another important thing is that we are not sure about the underlying hardwares. When you are using the cloud service, you may choose, for example, I need a 4-core CPUs. I need 8 gigabytes memories, and they just provide an instance for you. But what's about the underlying hardwares? It's hard to determine whether you are using a real or you are using a real computer, or it's just a virtual machines maybe provided by the Googles. So this is what I need to say about the untrusted platform. We don't know about the OS, we don't know about the hardware, so this is the problem. And another problem is about the safety of our programs. Because in this case, your programs have to be uploaded to the cloud remotely, and during this process, your program may be tampered, and during the execution, your runtime data may be picked. So we don't know all of this. There is no any security insurance about all of this. So this is the problem. And although we have some TE, and for example, the cloud service provider like Microsoft claim that they are using the TE, and for example, Google says they are using AMD SEV, but the first thing we need to ensure is that they are really doing what they said. So this is what's remote attestation for. Remote attestation is an important service. Go with the TE. For example, the Intel provide their remote attestation service just with their Intel SGX solutions. And then important question here is what to test. From my point of view, there are two things to test. The first thing is the integrity of the programs. Because the users, then you need to know the programs you uploaded is unmodified, and is just the one you have developed and compiled. So if we can attest the integrity of the programs, we can ensure that our programs are unmodified and just the one thing, just the thing we want. And another thing to attest it is the underlying hardware. We need to ensure that our programs is really executed in a real TE hardware instead of some virtual machines or some, I don't know, malicious constructed controlled hardware. If these two things have been attested, then we can ensure that our program and data are safe. The whole procedure of the attestation is really complicated, just like the picture I have shown here. I don't want to explain all the details here, and I will just give a simplified procedures of the whole attestation progress. The first thing you need to do is you just develop your program like normal, and then when you try to build your programs, an important things you need to provide with the programs is that you need to apply for an ISV certificate from Intel. Because here I use Intel SGX as an example. You first need to apply for a certificate from Intel, and then when you are compiling your program, you sign your program with it. So with this signature, we can know that first the signature can prove the integrity of the program. If we can check the uploaded ones and try to match the signatures. If they are matched, we know that the program is unmodified. Also, it can identify the authors of the programs. For example, Phala can apply for its own ISV certificate and sign our program with it. And when you get our distributed releases program, you can check our certificates and you know, okay, this one is really from the Phala officials, not built by the other parties. Okay, this is the first step. Then you just deploy your program to the cloud. Okay, the third step is the most important one, is that you can require an attestation report if your program is really deployed on an TE hardware. Then you can verify the attestation report, and you can know your program is unmodified and it's really run on a TE. Then you can confidentially use it without any worry about your privacy leakage. Okay, what the attestation report is about? It contains many important fields, and I just select some of the most important fields here. The first is the measurements of the code and data in the enclave. After checking, we can check the measurements of the code and data to ensure two things. First, our code is unmodified. And if the data is also unmodified, then we can know the initial state of our program is determined. Okay, this is the first thing to check. And the second thing is it contains a hash of the POP key in the ISV certificate. Okay, by checking the POP key, you can know that this program, just as I have explained, you can know that this program is really issued by the Phala officials, for example. The third thing is some security-related state informations. It's mainly include two things. First is the CPU microcode version. CPU microcode is some upgradable instruction set in the CPUs. The modern CPU is not just the hardware. The modern CPU contains two parts. It contains the hardware part, the logic, and another part is the microcode. So these two things work together to consist the modern CPUs. And we can, for example, after some bugs have been reported about the Intel SGX, it can issue some upgrade on the microcode to fix the bugs. And after we check the CPU microcode versions, we can know that, okay, some known bugs has been fixed. And also we can know that maybe there existing some other bugs is still to be fixed. So we can measure the security level of the CPUs. Phala used these features and proposed something called confidential levels to measure the security of an Intel SGX CPUs. The next thing is enclave software versions. Okay, I think this one is self-explanatory. After we check that the CPU microcode version and the enclave software version is both up to date, we can know that, okay, your CPUs is good to run, and there is no known bugs in it. The last thing is the enclave certificate signed by SGX private key. As I have proposed, there is some key pairs in the Intel SGX hardware during manufacturing, and it can uniquely identify the CPUs. And the CPUs will sign the enclave certificate with its private keys, so we can know that this certificate is really issued by the CPUs instead of others. For example, someone may just collect his own CPUs to sign a certificate and distribute that to you, and then you can also, okay, this is not the hardware I'm using. After we verify the enclave certificate signed by SGX private key, we can know that the enclave is really running in a verified Intel SGX hardware. Okay, here comes some conclusion of my today's talk. I think there are two security best practices with the TEs. The first thing is we should place the root of trust in hardware instead of the service provider. Because even if sometimes the service provider can be malicious, and sometimes even if they are not malicious, maybe their systems can be hacked, and some maybe attack. For example, if you and the attacker's applications are both deployed on the same version on the same machines, then the attackers he can just he have a chance to just break the limitation of the virtual machines and attack your applications. There is many things possible. Another thing is keep your data encrypted all over its lifetime, and only decrypt it in the CPUs when the execution is necessary. Okay, that's all my talks today, and here comes the Q&A. Okay, any question here? These are no. Yes, I think you can. The first question is there a repository of all the current use case designed or approved by the Phala team? Phala we have just enabled our security mining, and you can check our code base for it. And we have some branches. Because we have migration the support for the ink contract to Phala, but it's not released, and I think it will be released soon. And we have a hackathon, an encoded hackathon in September the 2nd. And I think you can check our hackathon to find some real use case of the TE we have implemented. What is the biggest advantages of Phala TE versus the current industry standard? Okay. That's really a big question. And in today's talk, I just talk about some technical details about the TE. But I think the biggest advantage of Phala TE is that we combine the TE with the blockchains. And actually, many projects doing so. For example, the Oasis Lab doing so, and the Secret Network. They also try to combine the TE with the blockchain, but Phala has some unique advantages, I think. For example, in our coming hackathon, we will show that the smart contract model of Phala is different. For example, we allow people to access the network in the smart contract. And I think this is the world's first smart contract model which allows developers to access network service in their smart contract. And after doing that, if you can access the network from your smart contract, then you don't need to rely on some heavy services, for example, Oracle, because you can just try to get the price of BTCs from network service instead of rely on some ad hoc oracles to do this. And I think, okay, welcome to our hackathon in October the 2nd. Okay, oh, many questions. How do you look at the continuity of following file state and how to get? Okay, we have some discussion with. I will answer the third question. We really have some discussion with Intel about these questions. And the 11th generation of the CPUs, they have removed the support of SGX in the 11th generation of CPUs of Core, but it's still available on their server version of CPUs. This is the first thing, and also Phala is also we are working together with the Google, because we are trying to support the AMD SEV. Also because we also concerned about the single point of failure problems if Phala can just operate on the Intel SGX CPUs, and which we are really trying to support more. But I don't think it's the first. It's the very prioritized, because we have many things to do. But our investigation shows that the computation model of Phala can really be supported by AMD SEV. So we will try to support SEV. Maybe I don't know, about half a year later. What would make Phala accessible into business? Sorry, I don't really understand the last program. What do you mean by in the medium term? Maybe I will leave this problem to our marketing colleagues. Can other blockchain use Phala for computational scale? Of course they can. Yes. An important question here, I think, is how other blockchains can send a message to Phala blockchains. This is an important question. And if you are a Substrate community, if you're concerned about Substrate, you will know that Substrate has proposed a solution called XCM, cross-chain messaging mechanism. The XCM is a standard try to design how blockchains communicate with each other. And if other blockchains they can support the XCM, then they can send messages to Phala and use the computational power of Phala, I think. Yes. I think the underlying mechanism of Phala is really complicated. That's why we try to give this series of talks to explain to our developer and the users how Phala works. It includes many serious technologies like distributed systems, trusted environments, and for example, the consistency problems across many nodes. But we don't want our developers to care about this. One thing we try to do is we try to abstract out the implementation details from the developers, and our developers you can just use the normal smart contract model, maybe a more powerful one. For example, the Phala will support the ink contract of the Substrate communities, and I think any developers who is familiar with the ink smart contract, they can develop on Phala. Does Phala have plans to secure any enterprise and customer partner in the near term? Yes, we have, but for some reasons I cannot leak that. ARM processor. Okay, talking about ARM processor, I have just mentioned the ARM solution of CCA, but unfortunately, I have heard that the CCA will be delayed. It's said that the CCA will. It used to be said that the CCA will be released in the late this year, but from the current situation, I don't think the ARM will release the CCA this year. Maybe I don't even think next year it will be available. Also, even if they have released the CCA, just like AMD, they have published the SEV for a long time, but the tool chains and the community, for example, the underlying tools, it needs time to develop. For example, the current AMD SEV solution only provide the development tool chains of Golang. That's why we don't immediately trying to support it, because anyone who concerned about our code repo will see that we developed Phala Network with Rust, and there is no Rust SDK for AMD SEV for now. Future to implement cloud computing games seamlessly, like okay, about the GameFi, yes. The GameFi is a very good use case of Phala networks. This is because the okay, I will come a little about the technical details. Phala have adopted a framework of the separation of computation and the consensus. So when we try to execute some smart contract on Phala, it's not like the EVM. You have to wait. you have to wait. For example, in each blocks, all the miners will execute the same contract, and the execution only happens when the new block is provided. And in Phala, this is different. In Phala, the smart contract is executed just like normal programs. That's why I say we will show how. That's why Phala can support smart contract, which can try to which can access the network service. Phala, the smart contract of Phala is executes real time. So I think it really can be used to power the blockchain gaming. Yes. Oh, the last question is this is very professional. Yes, TE can be vulnerable to Meltdown and Spectre programs. Yes, but first I think many if you okay, it's heavy reorder. If you have followed the development of Intel, you will see that Intel have released many security patches about such Spectre and Meltdown bugs, and more importantly, Phala have a confidential level mechanism, and the first and second level computer, their CPUs are known to, which can be they can resist the Meltdown and Spectre attacks, and we only run the very important services like our gatekeeper in the computer of the confidential level of 1 and 2. And also, I think an important question here is that even your smart contract is running on a computer with Meltdown and Spectre vulnerabilities, there is problems for attackers to try to attack them, because the attackers won't know where on which worker your smart contract is running. And Phala have job rotations, because after sometimes your smart contracts will be deployed to another workers. So the attack window, the time window for the attack is very short. So he need to first locate your smart contract amongst all our about now there is 10,000 workers. He have to first locate your smart contract. Then he will need to try to access. He will try to access to the vulnerable worker and attack it and get the result back. This is really hard, because even if the CPU is suffer some meltdowns and Spectre vulnerabilities, an attacker, if he really try to read something from the CPUs, he only can do that in a side channel way. And if you do that in a side channel way, it takes time. So I think the random distribution of the smart contract and the rotation of our work can help mitigate such problem. Okay, let's see any new questions. Future risk. Okay, for now, I think Phala is too young to try to replace the cloud service provider like Google Cloud or Amazon's. But I think it's really provides some unique features people may maybe appreciate. For example, I think we always say Phala has two major advantages. The first thing is that it's cheap, because we are using the extra computational powers from the workers' computer, instead of we buying all the machines ourselves. So this is the first advantage of Phala. We are cheaper first, and the second thing is that from its core, all the data in all your data on Phala Network is encrypted all its lifetime. So even we are the developer and designer of the Phala Network, we are unable to decrypt your data. And I think that's maybe appreciated by some people. Okay, since I have seen some very professional problem here, I will recommend you to read the maybe the wiki, and we have some documents about the design of all the Phala Network and our contract model. Also, we can maybe discuss further in the Discord. Well, welcome to drop your question to me. Okay, any more questions? Okay, so if there are no more questions, okay, I think yes, this is our first talk, and I'm a little nervous. And thank you all for coming here. Okay, and some advertisement here is that we will have an hackathon on October 2nd, and welcome to join us and see what we can do for now. And I think in the following times we will soon, maybe this month or the next month, we will enable the deployments of the Wasm contracts. So at that time, I think all the developers can freely use Phala and just deploy your smart contracts as needed. Also, if you have any also you have some advices or the preferred topic for our following talks, please just drop it to our Discord, to our Telegram. Okay. That's all. Thank you. Okay. Thank you. Bye-bye. Have a nice day.